Pleasant day to everyone. This time we will now consider Unit 7, which is the vertical stress below the center of a uniformly loaded circular area. Let us take a look into this figure. So we have here a circular load, and from the title itself, the point of consideration has only one definite location, which is below the center of a uniformly loaded circular area. So it is always at the center and it has no other location. For the other location, that would be another topic. For this particular module, the point of consideration is always below the center of the circular area. So the vertical increase at point A in the soil mass is given to be Q multiplied by 1 minus 1 divided by R over Z squared plus 1, the quantity raised to 3 halves. Wherein Q is the load per unit area, and then capital R is the radius of the circular area. And then, as usual, Z is still the depth from the ground surface up to the point of consideration. Also, considering method 2, the vertical increase at point A in the soil mass using table 3.6. So first is we have to determine the ratio between the depth and the radius of the circular load. And then we refer to table 3.6 for us to identify the value of C. And then after identifying the value of C, we can now substitute it to the equation for us to be able to get the value of the vertical stress. So this is the table that is being used for this specific type of load. Let us consider a sample problem. A flexible circular area on the ground surface is subjected to a uniformly distributed load. Q is equal to 105 kilonewton per meter squared. If the circular area has a radius r, which is equal to 3.6 meters, determine the vertical stress increase at point 0 below the ground surface along the center line of the circular area. In the figure, we see here the plan view. The figure above is a plan view, and then the figure below is the cross section. So we have here a uniformly distributed load, and note that the unit for the load is kilonewton per meter squared. So again, for point load, kilonewton only. For line load, kilonewton per meter. And then for this area, for circular area and rectangular area later on, that is kilonewton per meter squared. And then again, for this particular unit, the point of consideration is always below the center of the circular load. Let us identify the given. Q is 105 kilonewton per meter squared. Our radius is given to be 3.6 meter. And then the value of Z is 0. So using the equation 3.28, we substitute Q is 105 kPa. Our R is 3.6 meter. And then our Z is 0. Simplifying, we come up with the vertical stress is 105 kPa. Let us consider the method 2, which is the use of table. So first step is we determine the ratio between Z, between the depth and the radius. So that is Z all over R. Our Z is 0. Radius is 3.6. So 0 divided by 3.6 is 0. From the table, the value of Z all over R is 0. Therefore, the value of C is 1. So from the table, 3.4, C is equal to 1. And then substituting to the equation, 1 times Q is 105 kPa. Vertical stress in 105 kilopascal, which is the same answer that was solved in using the equation.